In determining the relationship between the state of compaction of the soil and the moisture content for the machine under test, the soil is compacted by a sufficient number of passes of the machine to ensure that little further compaction could be achieved. That is, the soil is compacted to refusal. With rollers, this is usually achieved after about 16 passes, but in order to be quite sure, 32 passes were given in these tests. The state of compaction of the soil is measured in terms of the dry density. That is, the weight of the dry material per unit volume of compacted soil. In order to ensure that an accurate and representative result is obtained, 10 determinations of dry density are made over the compacted area. Personal bias in selecting the points where these measurements are to be made is eliminated by employing a standard pattern. The method used for determining the dry density of the soil is the British Standard Sand Replacement Method, which is suitable for all types of soil. After trimming level the surface of the compacted soil, a hole about 4 inches in diameter and 6 inches deep is carefully excavated, all the soil from the hole being collected in a tray. The volume of the hole is found from the weight of closely graded dry sand required to fill the hole. A standard pouring cylinder is used to provide a controlled rate of filling, allowance being made for the weight of the sand trapped in the cone. The dry density of the compacted layer is taken as an average of 10 determinations, giving an accuracy of about plus or minus 1.5 pounds per cubic foot. In order to calculate the dry density, it is necessary to determine the moisture content of the soil. A small sample of the soil from the hole is taken and weighed. The sample is then dried in an oven controlled at a temperature of 110 degrees centigrade for 24 hours, after which it is re-weighed. The loss in weight of the sample, expressed as a percentage of the dry weight, gives the moisture content. After the measurements of the state of compaction have been completed, the soil is again broken up and prepared for the next tests. The compaction procedure and the density measurements are repeated with the soil at a different moisture content or with different numbers of passes of the machine. 3 main factors are studied in the tests. Firstly, the effect of the moisture content of the soil on the state of compaction obtained. This relationship shows the range of moisture content over which the machine can be usefully employed and the state of compaction which can be achieved. Secondly, the effect of the number of passes of the compaction plant on the state of compaction. This relationship shows the limited number of passes of the machine, after which little further compaction was obtained. A knowledge of this is essential for the efficient and economical operation of the machine. The third factor studied is the change in state of compaction of the soil with depth. This is found by making dry density measurements on successive 3 to 4 inch layers throughout the full depth of the compacted soil. The maximum thickness of the layer, which can be compacted satisfactorily by the machine, can be arrived at by these measurements. A knowledge of the 3 curves obtained on the test soils for various types of compaction plant enables the engineer to select the most suitable machine to be employed for any particular work. He can also specify the most satisfactory and economical method of operating the machine. Only in this way can the necessary standard of earthwork construction be achieved at the minimum cost.